Today, we spend 1.3% of the world's electricity running cloud computing. Projection is that we'll need 1,000 times more cloud computing in about 10 years from today. That's 1,300% of the world's electricity.
Starting in 2002, cancer began to kill more people every year than AIDS, malaria, and TB combined. And that's only gotten worse. Even here in the US, it's approaching the #1 killer, higher than cardiovascular disease.
I like to say water is sort of the one energy problem that could kill you. 2 billion people in the world today do not have regular access to clean drinking water. Within the next couple of decades, that's expected to go up to 4 billion.
MIT is a place where we think about solving problems in our society today, and we have a responsibility to actually come up with solutions and to show that science and engineering and technology can actually provide solutions.
Nanoscale happens to be the operative unit. If we can control it, we can build the world we want.
It's a natural platform for innovation and thinking about growing and transforming non-biological materials, but giving them some of the best properties of biology.
You think about the periodic table, it's as if you've given that whole table a completely new dimension.
Over the past couple of decades, the equipment and the experimental techniques at micro and nanoscales have evolved. I can't even tell you how much they've evolved. We can see things now that we couldn't have even imagined looking at 20 years ago.
Our present facilities are twice as busy than any other research lab in the world. Opening MIT.nano will enable us to fulfill our desire to be even more productive.
Innovation occurs when you get unusual pairings or unusual collaborations.
It's about sharing ideas. It's about working together to push the boundaries of what's possible. It's about what we can do as a community to make a difference.
Having a fabrication facility right at the heart of the campus really tells us that we are here to prototype and make things.
The way discoveries happen is that engineers actually tinker. We like to play, we like to invent, and so we might have one idea in mind and discover something completely different that has another application.
MIT.nano will house the most complex set of nanotechnology tools ever assembled in a single place. Tools that none of the individual faculty can afford because they're too expensive to maintain. But as a group of 2,000 users, we can certainly maintain it as a central facility.
When you get access to those state-of-the-art tools, you really start thinking big.
You have this spiral of technology development, fundamental science technology development that can start a real snowball effect. This is the time to build this building, because this is the time when the technology is really going to leap forward.
What we do is really on the edge of science and fiction. And if we make one more step, if we can make this particle a little bit more magnetic or a little bit bigger, a little bit smaller, then maybe we will be able to really change the way we interact with human nervous system.
We can envision a future where a large fraction, maybe as much as 20 or 30% of our chemicals actually come now from biology as opposed to from petroleum.
One of the dreams at MIT is to design what will be the first interplanetary small satellite to explore the moon or explore Mars or an asteroid. That would be unheard of.
MIT attracts people who see their mission to be beyond academic pursuits. Mind and hand symbolizes what we do. MIT.nano epitomizes MIT's mission. We think about ideas. We reduce them to practice, and then we give them to the world outside.
Good morning, everyone. It is fantastic to greet you this morning. My name is Vladimir Bulović. I'm the director of MIT.nano. It is truly a pleasure to have a chance to look at this video that was filmed about 9 years ago, to understand, have we actually lived up to the expectations and the promise that we have made back then? I hope as the day progresses, you find yourself amazed at the opportunities we have brought forward. And it will be told, these opportunities, to the words of my colleagues that will come on the stage one after one with groups of other colleagues to be able to hopefully bask you with new ideas, showing you the path to where the nanoscale is taking us. What my moment right now is to introduce John Roberts, the Director of Industrial Liaison Program, indeed the individual who we have partnered with to offer this particular program today.
And I'll make a reference to that too.
It is truly a remarkable partnership we have seen over the years. Engagement of industry with MIT.nano allowed us to build where we are today and expand our horizons beyond of what we have managed to do only on our own. But I'll let John say a few words and then I'll take back over.
Oh, I'll have a few more than just a few words. Oh, I'm sorry, that was the beginning of my presentation. So welcome again to the MIT.nano Summit that's in collaboration with ILP and Startup Exchange, and I'm really happy to be here to celebrate this day. This ILP and Startup Exchange, we are 57, that is, we are 57 people. We are also 75, you see what I did there? That was pretty clever, wasn't it? We are also 75. We've been around for 75 years in the form of ILP. This is the deconstruction of MIT, of Building 12, which turned into MIT.nano. And I just wanted to point out, as Vladimir just said, we have been supporters of MIT.nano since the very beginning. In fact, I remember walking around in the buildings that were not taken down, looking out through the windows with corporate visitors and pointing out, this is going to be a great building and great things are going to happen in it. And as I understand it, on budget and on time, it turned into this, which is truly remarkable. I want to tell you a story about this man, this molecule, and an Erlenmeyer flask. So the man, and that's exactly what we called him, he was my research advisor here at MIT in chemistry, Professor Satoru Masamune, and he had this habit that after you defended your thesis, you stayed around for a little while longer and you did a few experiments that were just on his mind. And he had me make this molecule, and he wanted me to get some physical property data on this molecule. I did make it, but it was very difficult to get the physical properties data on this molecule because of its very peculiar behavior. And one of the peculiar behaviors was in an Erlenmeyer flask, this is a 5-liter Erlenmeyer flask, if you just had 100 milligrams of this stuff in ethanol, it crystallized, sort of crystallized, to something that was one crystal, a long, long hair. And we could not figure out, with the simple methods that we had at hand, what was going on there, and we couldn't isolate it in the solid form. I have a feeling that if MIT.nano were around that day, this would have turned into an excellent PhD program for another student. So this is Sally Kornbluth. She is our president. She hasn't been in the presidency yet for a year. She will be speaking at there's a plug for our R&D conference. This is a QR code that you can use to register. If you're an ILP member, it's of course complimentary, but we're opening it up to a wider community for a limited time. And if you would like to register and are not an ILP member, you can use the comp code NANO23, and that'll be on the next few slides. So why MIT.nano? Why do you come and engage with MIT.nano? There's research, there's technology, and there's community. And even though you may be working on things that are really, really, really small, they're also important. And they help to shape and create our future. And this is why people come to MIT, just in general. So why would you engage with ILP and Startup Exchange? There are a number of reasons, but just to be really clear, we are not an organization that sponsors research at MIT. We help connections get made, we help build relationships, and we help people find each other in the larger community. In fact, we are extremely inclusive. In terms of MIT, we work with people that are across the entire institute. In terms of global corporations, we work with corporations across all industries. And in terms of MIT-connected startups, we work with startups that are across all technologies. We're also everywhere. At least this fall, it certainly seems like we're everywhere. We do events here, we do events in other parts of the United States, and we do events internationally. But we also set up meetings, not only at MIT, but elsewhere. It's really important to place us in the innovation ecosystem, because this is part of where our power comes from. So we bring to the table 3 of the 5 stakeholders of a successful innovation ecosystem, and they are the knowledge creators of the innovation ecosystem. Specifically, we work with more than 200 companies intimately at any given time. These are our ILP members. We work with thousands of people at MIT. This 1,000 plus is the number of faculty that are at MIT. And in terms of MIT-connected startup, we have a steady state of about 1,000 MIT-connected startups that are at an appropriate stage for connection with corporations in the way that we make connections. So since when have we been doing this? I've alluded to this one. For 75 years, we've been making the connection between MIT and corporations. And for startups, we've been doing it for 8 years, again, between startups and the very same corporations. Loosely speaking, this is ILP and Startup Exchange, 2 highly integrated programs. Again, placed in the innovation ecosystem, when you work with us, we put you on a global stage. And so that leads us to our byline, which is connections, relationships, global impact. And speaking of global impact, that's happening every day at MIT.nano. So happy 5th anniversary to MIT.nano and, of course, all of the people that worked so hard to make it successful. So congratulations.